Hello everyone, and welcome back to another GIS statistics lecture video. And in this lecture video, I want to make one point of clarification when we went through this sort of conceptual example before. And the clarification that I want to make here is that ZA is greater than ZB, right? And so if that's not abundantly clear, what I'm saying here is that no matter what geographic position these are in, we always want to make sure that the value that we assign to A, or I should say, sorry, that the point we call A has the larger value, so that ZA minus ZB will always be positive. Hopefully that makes sense. And the reason is because if ZB is bigger than ZA, this whole equation will fall apart and it won't actually work properly. So hopefully that makes sense. And what we can do here is we can then take this and we can go look at an actual example. So this is an example here. We have point A up here with a value of 7. This is the coordinates. And then we have a point B down here with coordinates. And again, the value of B is lower than the value of A. So what I've done here is I've calculated these distances in advance, so we don't have to go through that. So what we're going to do is we're going to just quickly figure out, well, what is this value x at point C? So all we're going to do is we're going to take, again, that difference in the value between A and B. So that's going to be 17 minus 8, right, divided by the distance between A and B, which is 5.66. And we know that that's going to be equal to the value of A, which is 17, minus x, right, because x is the thing we don't know, divided by the difference in distance between A and C, which is this 1.41, right? That's all, this is all linear interpolation is. So now we're just going to solve for x. So what I'm going to do here is I'm going to do 17 minus 8 over 5.66. We're going to multiply that by 1.41, right? That's what we're doing there, is equal to 17 is equal to 17 minus x. And then we're going to subtract 17 from both sides. So that's 17 minus 8 over 5.66 times 1.41. Make that clear that that's not a decimal. Minus 17 is equal to negative x. So what I want to do here, just to make sure we don't make any mistakes, is I actually want to calculate this out really quick, leaving the negative here. So 17 minus 8 is going to be 9 over 5.66 times 1.41 minus 17. So let's go ahead and do that math really quick. I'm going to pull up a calculator and we're going to do the math. We have 9 divided by 5.66 times 1.41 minus 17. We get a value of negative 14.75, which is equal to negative x. So then negative x and negative 14, we're going to swap that, and we're going to say that x is equal to 14.75. Now let's just quickly go back to our little diagram here and say, well, does that make sense? The whole idea of linear interpolation, and we're going to talk about this with inverse distance weighting in the next video, is that the closer the point is to a value, the more likely it's going to have that value. So the closer we get to A, the closer we're going to have a value of 17, the closer we get to B, the closer we're going to be to a value of 8. So does it make sense for a point that's this close to A and this far away from B to have a value of approximately 15? Well, yeah, it seems pretty reasonable, right? We obviously don't have good human visual ability to determine what value this should be, but it certainly seems reasonable, right? It's in the proper range. So this is, again, this is our value, right? The value at C is going to be 14.75. I hope that made sense. Again, calculating this by hand is probably not practical, but I hope that it just shows you the specifics of how that works. Thank you.